In our next few examples, we'll take a look at applying both methods to evaluate or to simplify some different problems. In example 14, we'll look at applying method 2, where we tackle the numerator and denominator separately. In the numerator, we have 8 minus the expression x plus 1 all over x. The common denominator here would be x, so we'll multiply 8 by x over x to get 8x, and if we distribute that negative through, minus x minus 1 all over x, or 7x minus 1 over x. In the denominator, we have 7 minus the expression x minus 1 over x plus 1. To get that common denominator, we'll multiply 7 by x plus 1 over x plus 1. To get 7 times x plus 1 minus x minus 1 all over x plus 1, which will give us 7x plus 7 minus x plus 1 all over x plus 1, or 6x plus 8 all over x plus 1. Now we can take those expressions that we've generated and put them back together as the new numerator and denominator of this rational expression. And continue simplifying this by turning it to a multiplication problem and taking the reciprocal of that second expression. To see what might reduce. In this case, the quantity 6x plus 8, we can factor out a 2, which will leave us with 2 times the quantity 3x plus 4. We don't have anything that will cancel or reduce, so our final answer here will just be the quantity 7x minus 1 times x plus 1 all over 2x times 3x plus 4. In example 15, we'll take a look at method 1, where again we take a look at every single term and find the common denominator. In this case, that would be x minus 3 times x plus 1. Even though it's not written, keep in mind that this expression, the denominator, is really x plus 1 over 1. So that doesn't really factor into our common denominator. What we'll do then is have to take our entire expression and multiply by whatever is missing to get that common denominator. So in this case, we'll multiply by x plus 1 over x plus 1 in that first term. In the second term, we'll be multiplying by x minus 3 over x minus 3. And then since the expression in the denominator doesn't have either of those expressions in its denominator, we'll multiply by x plus 1 over x plus 1 and x minus 3 over x minus 3. This is going to give us in the numerator x plus 1 times x plus 4 minus x minus 6 times x minus 3 all over that common denominator of x plus 1 times x minus 3. And then in the denominator, we'll have x plus 1 times x plus 1 times x minus 3 all over x plus 1 times x minus 3. We've got a lot going on, but things will start reducing and canceling and start getting a little bit easier for us. What we can do first is look at expanding what we have in the numerator of the numerator. So this will become x squared plus 5x plus 4 minus x squared minus 9x plus 18 all over that common denominator of x plus 1 times x minus 3. And then we can multiply by the reciprocal of the expression that we have in the denominator. So this will become x plus 1 times x minus 3 all over x plus 1 times x plus 1 times x minus 3. We have some simplification to do in the numerator of this first expression, but we already have some pieces that can cancel out. In the numerator, in this first expression, we'll distribute that negative and combine like terms, which will leave us with 14x minus 14, getting rid of everything that's canceled out. Then in the denominator, we'll have x plus 1, which you could write as x plus 1 squared, since we have two of those factors, times x minus 3. And then we could take this one step farther to factor out that 14 that's common in the numerator to get this fully factored and simplified expression.